Hello everyone, I'm Generation 3DX, a digital artist specializing in DAZ Studio and generative AI. As a traditional digital artist, you have likely seen the often superior realism that AI-generated art has and may have wondered if it was possible to distill your character's essence into AI and reproduce it to reap the dividend of that superiority. As an AI artist who creates art from text prompts, you have likely wondered how you could get the same consistent character coming through faithfully generation after generation. Both of these dreams can be answered in the words character LoRA, and in this video I'll tell you how it can be done on your own PC to create spectacular and consistent generations of your character time after time. So all the buzz in generative image AI is about this word, LoRA. What is it? LoRA is an abbreviation for low rank adapter. It's a bunch of AI tensors or math that modifies or adapts an image or video generation model to make it display something in particular. This could be anything, including an object, a scene, a color, a motion, an action, or a particular face or body feature. So there are many different applications for LoRAs. In this video, we are going to focus on how to make a LoRA consistently show your character's face and other characteristics of their body, such that when you create images with this LoRA activated, your character will come to life and appear consistently every time. The wonder of this tech is that if done right, your character's essence is learned by the AI such that you can reproduce that character in a range of styles, from full realism that will be even better than your previous renders in DAZ or Blender, to more stylized forms such as anime or Pixar. To do this on your own PC, you'll need a decent graphics card and CPU as well as a good amount of system RAM. But if you don't, then you can always train your LoRA online. There are many sites that offer this service, such as Civet AI, but this video will not cover that approach as we are focusing here on a local installation. The broad concept of character LoRA training is to take a series of images of your character, provide captions that describe these images, have the AI learn what is important about these images that tells it this is the character, while discarding irrelevant content. The AI goes over these images and captions again and again by generating an image from noise based upon the captions, and then comparing that image to the one that you provided, subtracting the difference from them to calculate a loss, and then trying again, all with the aim of reducing that loss so that it gets better at predicting the result because it has learned what your character looks like. There are a number of AI training suites out there. In this video, we are going to use Kohya SS as the trainer and Tensorboard to monitor progress, but the principles are broadly the same for any kind of LoRA training. The steps that we will cover are as follows: installation and setup of Kohya SS and Tensorboard, selecting a series of images of your character for training, providing captions to go with the images, configuring your training run, starting and monitoring the training, testing the LoRA for consistency and quality during and after training. Okay, so let's briefly talk about the installation of the tools that you'll need. Here is the Kohya SS GitHub repository, and you'll know it's this one because it's got this index, B. Maltais, he's the author. How you install Kohya is going to be dependent upon whether you want to use it in a Docker system, whether you're using it in a virtual environment with Python, and so on. I'm not going to go exhaustively into how to actually do this because it's going to depend on multiple different factors, and you're just going to have to work your way through the README file that comes with it. It's quite exhaustive. Just get some AI help. You use your favorite AI, Grok, ChatGPT, Gemini, to assist you on this, but always bear in mind that AIs don't always give you the correct answers. Okay, and it's also going to depend upon whether you're on Linux or whether you're on Windows or Mac and so on. Notwithstanding, I will explain how I do my Kohya SS installation, and it is on a virtual environment within Python. So you have to have Python installed, at least if you're going to do this local installation this way. So you need to have Python installed on a virtual environment, because you don't want any of the libraries that you're using with Kohya SS to interfere with any libraries that you might be doing for your AI image generation, Comfy UI, and so on, so on, so on. So you don't want to get those Python libraries mixed up, so you keep them all in separate virtual environments that completely self and sealed containers effectively that don't interfere with each other. Doing that virtual environment is pretty straightforward. I actually have a script. I use a script that I have on my that I've set onto my desktop to activate it. It's simply you go to your installation directory where you clone your GitHub, where you clone the repository from GitHub into Kohya SS, and then you activate the virtual environment using activate, and so on. And that basically, by kicking this off, I can just open a command prompt, and then I've got my virtual environment all ready to go. I can then start typing in my training commands and so forth. Very straightforward. Well, I think it's straightforward now, but of course you have to go through the various steps of understanding what's involved. And once you have that down, it's fine. To install Tensorboard, you can either go to the GitHub repository, which is TensorFlow Tensorboard. This is for your monitoring suite, which is vital in order to do your training efficiently and effectively, to monitor your the loss rates. Or if you're in your command prompt, it's just simply pip install Tensorboard. I've already got it installed, so it's going to tell me I've already got the requirement satisfied, but it's that straightforward. Okay, and we're going to pick up later on and actually activating Tensorboard. We'll talk about that later, but installation stage right now. So the only tools that we do need are Kohya SS, obviously Python under all of this, and Kohya SS. And also you're going to need a checkpoint to actually do your training on, but we're going to talk about that when we start the training. As you're going to be doing potentially quite a lot of running of scripts and arranging of files and so forth, I personally find Microsoft Visual Studio Code is the best way to manage your whole kind of process as you're doing all this. In this way you can keep track of where your configuration files are. So you can also monitor your data set of images, various things, various factors, various artifacts that go into the management of this whole system. Otherwise, you're going to just be working in Notepad, sending yourself crazy, trying to find which file is going where and so forth. So Visual Studio Code, it's a free download. If you don't already have it, I thoroughly recommend it. And all you need to do is when you start up Visual Studio Code, you just say open a folder, and you select your installation folder where you've got Kohya SS as your root. As you can see, it's got it there as the root there, and basically it lists out every single file in that entire in the whole hierarchy is there for you to actually view, make edits to scripts and config files and so forth. Okay, so as a general comment, I'm going to be doing everything in the command line, and before you freak out, trust me, I personally think that GUIs, user interfaces, are actually a hindrance personally. They're too complicated. You've got to figure out where to kind of make adjustments on each of these different window text boxes all over the place, as opposed to just working from a single file, basically, which has got all your settings in there. You can see them all straight away. Okay, so we're going to be doing everything in the command line and using configuration files. Now, as I'm a coder in real life, for my main job, that comes more naturally to me. But once you kind of just get over the hump psychologically of thinking, scary command line or scary text, it's actually, I personally find it's a lot more sane to do it this way than trying to kind of mouse click your way around a very complicated UI. Okay, that's just my opinion on it, but hopefully if you do want to use a UI, you can do so. I'm going to be covering it here, but the principles is what we're trying to we're not getting in too much into nitty-gritty procedure on this. It's going to be more about the principles and understanding what you need to do, and those will apply whether you're going to use a UI or whether you're just using the command prompts and text files. We've got our trainer Kohya SS installed, we've got Python installed, we've got Tensorboard installed. So now we're ready to start looking at the source of the LoRA. And what is the source? It is images of your character. Okay, in this case, those of you who actually know me well and know my videos will know this character. She is Joni, the Scottish redhead, and she has many images that I have created, all in DAZ Studio. So they're all DAZ renders. Most of them I can't show you because they're not suitable for work, but you can see by looking at the ones which are that she has a consistent look that comes through on all her images, because she's a DAZ creation, so she's 100% consistent in terms of the position of her eyes, nose, mouth, her body shape, and everything. It's a very, I mean, that is where DAZ is absolutely excels, essentially. So we're going to use her images, and here I've got 121 images of her, okay, all in different poses, some with different hairstyles, different clothing, many without clothes, and that's an important, I'm joking around here, but if you want to recreate her whole, that means how her anatomical elements look, you know what I'm talking about. You obviously want to have pictures of her without clothes, because the trainer is going to use not just her face, but her anatomical elements also, in order to basically create that full picture of her. Also, generally speaking, is the body shape. If you can see her body shape without clothes, and it can replicate that body shape consistently, and it does do so when you do it correctly. It's amazing. Right, so we've got 121 images of Joni. Now, this is going to assume, because we have SDXL, we're not going to be using SD. So SD is stable diffusion, which is 512 by 512 pixels. That's now like, passe. We're now using 1024 by 1024 pixels, which is SDXL, standard diffusion extra large. So all the images that you want should ideally be 1024 by 1024. It's just going to be simpler that way. Now, if you decided that all of your pictures were going to be of a portrait, meaning that they're going to be taller than they are wide, okay, go ahead and do that. But potentially that's going to limit what you're going to be able to produce in inference, at the end when you're actually generating final images with your LoRA, with your character. So I would strongly recommend that you just keep a square ratio, 1:1 aspect ratio for all your images, and just make it 1024 by 1024. If you want to kind of get into more advanced stuff later on, do so, but if this is your first time you're doing this, keep it simple and keep it at 1024 by 1024. So you're going to have to just using whatever program you're used to, like Photoshop or anything like that, or GIMP or whatever, to crop the images of your character so that they're going to come out at 1024 by 1024. Now in this case, you got to think, okay, so you got to think about the fact that you need at least 50 images is your absolute minimum for getting some kind of character training, character LoRA. Ideally 100 or more. You think, oh well, I don't have 100 characters of her on her own. Chances are you'll have her with other characters. So what you can do in the case of, you can see here, so this is Joni with Natalie, but we've had to cancel Natalie. Like Stalin did with erasing the pictures of his former revolutionaries. They were erased from pictures. You want to use an eraser brush to just erase. You don't want to have any other faces on there, and ideally you don't want any other body parts as well. I think I've got one here. I just about got away with it, but that again could potentially be rather confusing to the trainer to have Natalie's hand there, thinking, well, was she's growing a hand out of her arm. I wanted that particular shot because I wanted to capture the side view of her body there, so it could actually memorize her ass and so forth. Okay, so you just spend a bit of time. It takes a bit of time, I'd say a few hours, maybe 1 or 2 hours, to actually crop the images to 1024 by 1024, resize, and also edit out any other characters that might be in there. So the goal is you're going to have 100 plus images of just Joni on her own, 1024 by 1024, and that's it. So that's your image set. Okay, the other half to the training is the captions. Now, if you are masochistic, you can go and manually write all those captions yourself. And I say masochistic because it is incredibly time consuming, and the chances are you'll get it wrong, because there's a whole art to captioning and creating captions, which the trainer, as I intimated earlier, the trainer is going to use those captions to try to create an image separate to your image based on just captions alone. Okay, just imagine that you're typing in, let's say we've got here 119, Joni 119. Okay, now these are auto captions here. Okay, so we've got our keyword here. We're going to talk about the keyword in a minute, but we've got basically a bunch of tags to describe what that image is. Okay, so we've got pink bikini, we've got realistic because it's photoreal, one girl, solo, long hair, breasts, brown hair. Well, she hasn't got brown hair, she's got red hair, but so that's wrong for a start. Ass, so it's definitely figured out the ass. Okay, lips and freckles, she's got freckles. Okay, so how would you know to type those in? You don't. I mean, what you would probably think of is, well, I'm just going to describe the image. So you say a redhead girl who is smiling, looking at the camera, side profile, and so forth. Yeah, you could probably do that, but how do you know that the trainer likes those tags in that order? And do you know if it likes natural language versus a tag format? You don't. So what you do is you don't do it yourself. You have a script that does it. You have an AI that looks at the images and figures out what is in the image, and it will consistently then create tags. Now, Kohya SS comes with a choice of different captioning, auto captioning utilities that you can use and scripts that you can use. I went around the houses on this and lost at least half a day, possibly almost a whole day, pulling my hair out, trying to kind of work out the best auto captioning tool to use. I tried Blip and it was a complete dead end, and next time I'm in San Francisco, I'm going to firebomb the Salesforce Tower because I just wasted half a day of my life on Salesforce Blip. Anyway, the one I basically settled on, and which I have found outrageously successful, is a WD-14. Okay, and as far as I know, that comes included with Kohya SS. If it doesn't, there is an easy way to install it. I can't remember off the top of my head, but just ask an AI how it can be done, or just check the docs. So what you have is this script here, which you don't have to be concerned about in terms of what it's doing so much, is it basically will go and look through the images that you have. And I've actually just created a copy here of because I don't want to change the captions that I had on my previous one, because I might want to do some further training on that. So we have all the different images that we have here, 120 images. So what we can do is we can have the script go through and look at all those images and make it guess what it thinks it can see. And the way that you do that is you run a command, and you go to the directory that that has the script in, and paste in the I've got this saved from earlier. I won't go through all of these different things, but there's some documentation on which switches to use in order to get your tags to work. I'm just going to note there's a custom tag that I created here called a trigger tag. And this has got the actual, and we're going to talk about what the trigger tag is. The trigger tag, if anybody has ever used a LoRA in AI image generation, you'll know that you need a trigger word to actually activate that LoRA so that the inference engine knows that it needs to incorporate that. So that trigger tag is going to go at the front of every single caption that you're going to make, because we're going to create a caption for every single image. Each image has its own caption file. So it's going to be 121 images, which means we'll have 121 caption files. We want those caption files to have our trigger tag, which is something unique and doesn't necessarily describe what it is. It's just a name. It's a tag that's it could mean nothing. It could say London or Paris. Well, you don't want to say London or Paris, but it could mean, you know, whatever. It's just a tag. And it's just a series of characters that says this is saying on every single image at the very, very start, it's got that tag there to say this is basically my character. Okay, so I just worked with an AI to with Grok to basically say, how do I modify this script to basically include a trigger tag and put that trigger tag in at the start, and it basically says, yeah, go and change this line here. I've actually got it here, I think. Yeah, prepend trigger tag if specified and not already present. So there, it basically will put that in. So yeah, it goes in there as an argument trigger tag. So I added that one in, e.g. Gen 3DX journey. So basically, I was able to just make a change to that script. I was able to make a change to that script to add that in. So here we've got this trigger tag here. I think that everything else is pretty much a standard tag. So let's kick that off and get our captions created. So you can see here it's actually 112 images, so I must have some gaps or something. So off it goes. It's busy doing its AI magic to basically, you can see here it's starting to create all these different text files now based upon what it's seeing in these images. Okay, so that's now finished. Now you'll see here what it's done is it's added in the frequencies that it's found, that it's identified. Okay, so it creates the captions and then it lists at the end how many times each tag has appeared throughout the whole set. So we can see we've got one girl, as predicted. One girl has come through on 110 different images. Okay, and amazingly enough, it's picked up that Joni has got freckles in 99 of them. She's Irish, so she's got freckles. And as we go down the list, we can see all these different tags that it basically is finding. Some of those are quite rude, so try to avert your eyes. And as we get further down, we get into just silly stuff. I mean, there's even one halter neck there. Yeah, she's actually got a halter neck dress on one of them. I can't remember off the top of my head which one it is. So that is done using the tag. Now, I cannot remember off the top of my head whether I actually asked Grok to create this addition in the script for me to actually do this, or whether it actually comes included. So if it doesn't come included, then just ask Grok or Gemini, how do I want to actually modify the script, modify the tagger script to basically give me a list of how many times a specific tag has occurred throughout that captioning run. Okay, the reason that we're interested in these is because we need to identify tags which we actually don't want, that we don't want to put in our captions. By the way, so let's just have a look at one of these files. So we've got the image there, 120, and we look at what caption it's created. So we can see we've got our tag, that's at the start, our trigger tag, Gen 3DX Joni. Sensitive is a word which simply describes whether it's explicit, whether it's safe or sensitive. Because there's a lot of flesh showing, it's put it as sensitive because it's not totally sure if it's okay suitable for work or not. We've got one girl solo, long hair, breasts. Well, yeah, she's a girl, she's got breasts. She's looking at the viewer. She doesn't have blue eyes, so that would be one to correct. She's got green eyes actually. She doesn't have brown hair either. She's got red hair. Okay, she's sitting, yes, that's correct. She's got a swimsuit on, bikini, that's fine. Small breasts, yes. Barefoot, well, just about. And she's got nail polish on. Right, blurry, that's something we don't want. Okay. A blurry background, yes. Right, so, and freckles. Realistic pink bikini, poolside. Pretty clever, really, isn't it? Considering that, you know, a human being never actually saw that and actually put that together and inferred that content by breaking down those pixels. It's magic, really, isn't it? This is a subject which it's kind of difficult to teach. You know, what tags to have in and what tags not to have in. You got to think about. You trying to got to think, get your mind into how the AI is doing its job. The AI is basically trying to recreate images from noise based upon these tags. Okay, so if you are, you know, if you have tags that basically aren't relevant to describing a red-headed girl in a bikini sitting but on a poolside, then it's probably not relevant. It's just noise. Okay, if you, I mean, for instance, blurry, we don't want blurry in there. Blurry is that's irrelevant. Okay, you could have others like that might creep in, general stuff like fashion or style. Then it's meaningless. Okay, so you can see straight away if something is coming through. You just have to kind of get a feel for what is just not relevant. You can have a conversation with an AI about this to try to get it, but I had to go round and around and around before I really got it into my head. And perhaps I don't fully have it into my head because I'm not able to explain it to you exactly what it is that you need in order to actually remove tags that just are not relevant. Okay, the goal is ultimately to leave in the tags that consistently describe her face, her hair, a body and a pose, so that we can get her identity coming through across the entire set. So once you have identified which tags are undesirable, you can then actually put those into a switch to then rerun the tagging process, rerun the script again to say don't include those. And the way that you do that is with the undesired tags switch that goes into your tagging script run. Okay, so you do undesired tags and then quote, and then the comma separated list of tags unquote. And then what it will do is it will then not include those in the final set. So that's as a first pass. You see which tags are coming through as nonsense, like depth of field. There, you wouldn't have depth of field. That's just dumb. That's just talking about a style of camera, a use of a camera. So you wouldn't have that. But here, covering breasts, I can't show you that picture because it's not suitable for work. But there's one where she's covering her breasts. And that is something you definitely want because that's a pose. It's describing that. So if it's trying to recreate that image from scratch, from noise, based upon your prompt, and try to basically train and understand the difference of how to get the difference from your image, which is, you know, a manual image, versus its attempt to create that image from the prompts. Covering breasts is definitely something that's going to help train it and understand that it needs to actually, in order to actually get that loss, the difference down between its attempt to do it and your actual image. Right. So once you've got those, you will then rerun the tagging script with your undesired tags in, and then you'll get a second pass which has got a much more refined set of tags. And at this point, you do have to do some manual work to, for instance, take care of wrong stuff like this. So here, blue eyes would be green eyes because she has green eyes. That is an absolute character, very important character thing. So we can say red hair or possibly ginger hair. Ginger I think is a safer bet because red hair could mean, you know, somebody who dyes their hair spectrum bright red, you know. So I think ginger is usually the best one. best one to go with. Okay, so here you're removing obvious errors, and you just have to do that one at a time. It can take an hour or two to do that. So it is quite a labor intensive process, even with the scripting and the automation that we have going on here. But I can't stress enough how important the captions are. I mean, they are absolutely, you can't bypass this. You can't just kind of do a shortcut. There's no shortcut to this. You have to have really high quality captions, because again, thinking about the process, the AI in its training is trying to create an image purely from text alone and then comparing it to your image, calculating a loss, and then coming back again and trying it again until it figures it out. Okay, so your captions are absolutely critical. So once you've got all those captions assembled with your files, with your image files, we can now go on to the next part of the process, which is configuring the training run. So let's do that. So the way that Kohya SS works, certainly as it is right now, is that the training command is actually really straightforward. It's a very simple training command, and it's just simply this. It's Python or py sd scripts. This is in your root directory of Kohya SS. sd scripts sdxl train network.py, sdxl train network. There is a different train network. You can see here, it's here in the root in sd scripts, sdl train network py. Okay, you don't need to worry about what's in this file. But you can know that there are other things like train network and so on. So we don't, that's standard, that's basic standard stable diffusion, not SDXL. So we have a specific train network script that we use. We have a specific train network script that we use to run. Okay, and the only well, there are a few more arguments that you can add later on, but the essential argument, you can actually run this script with a single argument, which is config file. Okay, and here we're pointing the config file to a TOML file. Okay, so let's have a look at this TOML file, because it's all the goodness is in here, and there's quite a lot to unpack here. Okay, so this is essentially the entire configuration of your training run. This is telling the AI how to compare your images to the captions that to the captions that you've provided for it, in order to calculate those, in order to attempt to create that image from the captions, and then calculate the loss, and then go back and then time and time again to do it. So these are all the different tools. The first thing you want to thinking about is what checkpoint to use. Okay, now when we're talking about checkpoint, we're talking about a model, an AI image inference model. Pony, Juggernaut, Cyber-realistic Pony, Cyberreal. There are so many out there. There's tons of them on Civet AI, ones that relate to anime and so forth. Okay, thinking about whether you want your character to be how you want your character to be represented in text to image generation will influence which model to use. I have got fantastic results with Pony Realism version 2.3, which is the current version at the time of this video. I'm tempted to want to try Cyber Realistic Pony because next time, because on inference I get even better results with Cyber Realistic Pony. Okay, but this you need to have that obviously downloaded in your on your system. So we can see here I've got Cyber Realistic Pony here, but I could also have Pony Realism version 2.3. So it's the exact same model that you use when you're actually doing text to image. They're the same models. So while we're here, by the way, in Comfy UI, which is this is it's a standard way to actually set up text to image prompts. I'm just going to do a brief pause here in the process, because you're probably exhausted by now with having to do all the scripting and stuff, just to show you what effect we're going to see at the end, so you feel motivated to keep going. Okay, I actually have just generated this just now. If you don't believe me, I'll do it again in real time, and you can watch, because it was loading the models. So let me just do another image generation here. I'm getting all my keyboard shortcuts here mixed up here, right? I was doing pause and play instead of on OBS instead of doing the run. Let's just click the run button and go. Okay, this is with my LoRA loaded in. Okay, this is the final LoRA that I made a couple of days ago. Okay, and that's pretty much Joni, isn't it? That definitely looks like her. We'll do another one. Yep, that's still Joni. Hi Joni. She's a bit stylized there, but it's still her, isn't it? Okay, now that works because I've loaded it in. She's loaded in. Okay, there's my LoRA, the end product of what we're going to do here. Now what happens if I turn that off and rerun it? So we've got here our text prompt. There's a bit of a duplication there, get rid of that. We'll leave it in there, but it's just that's going to be meaningless. See, that's our trigger there, Gen3DX Joni, right? It's meaningless. It won't know what to do with it because we've turned the LoRA off. Okay, so we're saying we've got grey green eyes, it's all this kind of stuff, and you know, photography and all this stuff. By the way, that prompt was an absolute masterpiece of crafting. It took me about a whole day to figure out how to get that look. Anyway, although I had a bit of AI help. Let's run this. There's no Joni LoRA now. Okay, so what it's going to do, Pony Realism, is it's just working on its own. And there's your pony face. there's the face of the AI girls that you see littering the internet everywhere. Okay, let's see if we can get another pony face. Ah, there's another pony face. Oh, and another pony face. What a surprise. We turn the LoRA back on, rerun it. Our activation word is in there. It's going to run the LoRA. There's Joni. Welcome back. Isn't that magic? It is magic. Okay, but anyway, let's not get carried away, because we're going to come back to this after we've done our training run to basically go through inference testing. So I mentioned cyber realistic. So the reason pony realism was a choice that I made. Just going back to our Visual Studio, you can see there it's the same checkpoint as that. Okay, next time around I'm probably going to go with trying to do the training with cyber realistic pony, because I think the results that come through, certainly on inference of cyber realistic pony, are even more they're breathtaking. I don't know about you, but that looks amazing. And actually, I think she's more faithful. Weirdly enough, she's coming through more faithfully. I mean, that's closer to her Daz character than Pony Realism was. So that is something I haven't completely figured out or managed to understand why she can come through more clearly and more faithfully on a different engine than the one that I actually used to do the training on. Okay, all right, enough of that eye candy. Let's get back into the trenches, and we're going to do this training run. Okay, so there's our pre-trained model name or path. Okay, Pony Realism. Our output directory is where the LoRA is going to be generated. Okay, so it needs to be a suitable directory there, and then you give it a name. So that's the name that's going to add to the file name. Okay, precision is important. Okay, I'm using floating point 16 BF, which I can't remember what off the top of my head BF is. It's more of a modern standard than FP16. I have a 5090 card with 32 gigs of RAM. You might not have as much RAM as that, and a lot of these settings are going to be related to how to get your RAM down. Okay, how to so that you don't go out of memory. in doing this. I'm using the best one, which is BF16 for the best fidelity. You might have to go down to FP8. This is something you're going to have to do a bit of research on based upon the card that you're using. But if you have a 4090 or a 5090 with 24 gigs of RAM or 32 gigs of RAM, just go straight to BF16. It's an absolute killer. Your batch size is going to determine how quickly it can do it. If it can add in multiple threads at the same time. If you've got the RAM to do that, definitely crank that up. I think I might even be able to get away with 4 there. I don't know. This one it's extremely important. Okay, it's your learning rate. What 1e to the minus 4 is basically 0.4 zeros, 0.00001. So that just means exponent to the minus 4. Okay. 10 to the minus 4. 1E04 or 5E05, which is half of that, are usually good starting points to do this. Okay, but this is absolutely critical, because if your learning rate, which is the steps that the AI trainer takes in order to jump from one guess to the next, it's how big that jump is, and it's trying to jump from one idea to another idea, in terms of trying to recreate from noise the image that you've given in the caption to try to match your image. Okay, that's the learning rate. If it's too much, then it's gonna jump over things and end up overfitting. And overfitting is basically where it ends up fixating upon things that are not your character, such as something that's going on in the background, and that the background can end up coming through on your inference after you try to start to use the LoRA, and that's when you know you've got overfitting. Overfitting it's a big subject, and it's one of the big gotchas and pitfalls, if you like, bogeyman of LoRA training is overfitting, and it's a massive subject, and it's something I don't want to belabor too much here. If your learning rate is too low, well, firstly, it's going to take longer to do the training, and I believe that was the only pitfall to it. But it turns out that if your learning rate is too low, it can actually get stuck and can't actually move forward and break out of some kind of hole that it's in able to kind of figure out what's the next step in order to guess the next step in recreating an image. So this is something you're going to have to experiment with, but a safe bet is 10 to the minus 4 to start with. Okay, and then that you're going to be pretty much. It's a nice safe bet to begin with. You may want to later go back and do a fine tuning with a lower learning rate once you've got close to that the goal. But for now, you just start out with a 10 to the minus 4. Warming steps, it's not massively important, this one. This is more about it ramps up at the beginning, so it doesn't go unstable at the beginning. So it ramps up your learning rate for the first 200 steps, up to your maximum learning rate there. Okay, training epochs is how many times over it's going to go over the whole set of images. You can put in a big number here, because I mean you can basically stop the run at any time, or you can start to do testing while the run's going on if you actually have a second video card or space on your RAM to do that. Optimizer type, just leave that at Adam W. That is, Adam seems to be pretty much the standard, and in fact I even heard John Colmack, the creator of the Doom game, he gave a talk the other day. He mentioned Adam briefly, and I was like, oh my god, I know Adam. Anyway, network module is that's just a standard fix there. Network dimension and network alpha, these two are very important. Okay, the higher this is, the more RAM it's going to use, but the higher fidelity that you're going to get on the crispness and the detail of your LoRA when it comes out the other end. So if you want to get really nice high fidelity, such as the shape of the eyes are particularly important because they so much determine the essence of a character. High is good. okay, but chances are your video card might not be able to handle it. 64 I think is a good safe bet. This one I was able to crank it up to 128 and I got away with it with my RAM, and it created an absolutely beautiful result. Network alpha is typically half of what your dimensions are. There's a bit more to that than that. You can ask the AI. You can have a conversation with an AI about the relationship between network alpha and dimensions. But this can, and with keep tokens particularly, this relates to character LoRAs, and it's important that you have that in. It's either 1 or 2. I actually cranked it up to 2, and I actually had even better results there. And then keep tokens. It relates to preserving a state, I believe, from one training epoch to the next. Don't fully understand it, but the AI just says no. Just go with 1 or 2 on that for preserving character. Caption extensions, pretty obvious. That's your text.txt for your caption files. Shuffle captions, leave that off. Definitely turn that off, because you always want to have your trigger tag at the start of every caption file. Okay, save every n epochs. If you don't want to have your hard drive littered with hundreds of megabytes of LoRA checkpoints that it's creating along the way, then you might not want to have that set to 1. But I have that set to 1 because when I do that, I can check and monitor the progress of the run as it's going along. And I can just take a checkpoint out and then see, right, okay, I can see that one. That's still rubbish. I'll keep going. Enable buckets is a RAM saving technique. I just always have that on. Xformers is an optimizer. If you have Xformers enabled, then it's supposed to speed things up. But I find that installing Xformers is a complete pain in the arse, so I didn't bother with it. It wasn't required. Gradient checkpointing is important for saving on RAM. Low RAM false. I turned it off because I didn't have a problem with it, but you may need to have that set to true if you've got issues with your with your video card being only 12 gigabytes or 16 or something like that. Cosine with restarts is a standard scheduler for the learning rate. What that means, it starts the learning rate off. Obviously you've got your ramp up there. It goes up to 10 to the minus 4, and then gradually over time it reduces it in a kind of a cosine, like a curve, so that when you finish your run at the end of 24 epochs, and this is where this number can come in important, is if you have an idea of how long you want to do the training for, then it'll gradually smooth out the learning rate, so that at the end the learning rate is a rate, it's like trying to put a polish on slowing the learning rate down toward the end of the training run, so that it's just doing fine details and stuff like that. You have no idea how, this is such an art. There's a lot of science and tech that goes into it, but doing it to get great results, it really feels like an art form. Right, so the logging directory is important because we're going to be doing that for Tensorboard, so that needs to go in. Cache latents definitely goes in because that's basically just makes a copy of the latent space of every image in your training set at the start, and then it just puts that into memory. So it uses a bit more memory to do that, but the performance benefit is huge. Persistent data worker loaders, just always have that set to true. This one here was Grok advised me, or was it ChatGPT advised me to turn that on, and apparently that makes a big difference. I can't remember what it does. Again, you can ask an AI. I don't want to spend hours and hours going through all of these and discussing the fine details of them, but I have covered at length the important ones, and this obviously is a very important one here. Okay, so you've got 2 sections. You've got general section and you've got your dataset section. Resolution is obviously what it says it is. It's 1024 by 1024. This needs to exactly match the resolution of every image that you have in your training set. These two combined this is the number of times over in every epoch it goes over the whole set of images to make an estimate through its noise calculation on your captions to try to recreate those images. Okay, that number there can influence how well or how quickly the training goes and how effective it is. ChatGPT said that 10 to 15 is good. Okay, and I have never gone outside 10 or 15 on that. Okay, your training data directory is basically what it says it is. If we look here, we've got Go to our it's where our directory of images is. Yeah, so we've got here Kohya SS dataset Joni SDXL. Okay, well, in this case it would actually be, if we're going to do this, we're gonna kick off this run, but I'm not going to spend the next 7 hours recording it, which is just a demo that we're actually going to kick it off and see where it goes. I'll change that one as well because I don't want to overwrite the existing stuff that I created the other day. And we'll just say demo here for the output name. Right. So yes, that's our directory of images, our training set, and captions. This number here, for some weird ass reason, you have to put in a subdirectory below this one, and that number has to match that. So if that was 15, that would have to say 15. Don't ask me why. It's just a quirk of Kohya. Okay, I mean, that can be anything you want. That could be 10 for hoodle for a we care. It just needs to have that number there, and why it does, I don't know why. That's your TOML file. Okay, if we go back to our command prompt, so here we've got our SDXL train network py and our config file Joni SDXL. All right, so let's just get this command going, and then we'll kick it off and then see what happens. So what it's doing now is caching the latents as a first step. It's not doing the training yet, but it's got the 112 images, making a copy of all that important info. I don't think it puts it in VRAM. I think it puts them in files, but otherwise it would have to do this every time on every run, and it would just be duplicating itself into oblivion, taking too long to do it. If you get any error messages when you're doing this, don't ask me in the comments, because well, you can, but this is not going to be a support based channel, because you can have so many different things go wrong. You just have to work with an AI like ChatGPT, Gemini, or Grok, and it will try to help you through it. Or you go and consult the documentation, and if you get really stuck, you can go and ask on the discussion board for that on the GitHub page. Right, okay, so it started training, okay, and it's in the first epoch, and this is going to be the total number of steps it's going to do, with an estimate of how long it's going to take. It won't be that long. This one will end up being, I think, about 12 hours, maybe 10. So while that's going, let's go and monitor. We can monitor the run in Tensorboard. Right, so you've got Tensorboard set up, so you just want to open a separate command prompt, and then we just paste in, I just made a copy of this from somewhere else. We want the log dir to match the log dir that we've got here. So we've got D development Kohya SS logs Joni, so we say logs Joni here. And the command is very simple, it's just Tensorboard. And this can be run anywhere, pretty much. Once you've got your Tensorboard set up and it's in your path, I believe it sets up in your path, and then you can just run that. So what that does, it creates a web server. You can access it on localhost 6006. So let's go over to our web server. Okay, so here's our Tensorboard setup. Now you'll see here I've already got some old runs that I did previously, which were in the same logging directory. So here we actually can look at the previous run that we did. If you look at our training prompt here, we can see it's at step 160. So there's our loss. Here's our loss curve here. It hasn't quite updated it. It updates it every 30 seconds. And you can do that in the settings. If you're wondering how to do that, there's a setting where you can just say trigger a refresh every X number of seconds. So this is definitely our run, and we've got here 2025-07-11, and that's today's date. So what it's done is basically it's ramping up. You can see that we had the ramp up on the learning rate. It's gradually ramping up that learning rate from 5e to the -7. It's going to eventually get there in 200 steps, and then it will flatten out. So we'll come back to that in a minute. This is the curve that you're going to be interested in, the loss average curve. Okay, so remember we talked about loss. Loss is the difference calculated difference that the AI engine had in trying to kind of create your image based upon your caption, and the differences it found. Okay, so that's what loss is. It's a fundamental concept, and once you have that, then it helps you understand that the lower the loss is, the better it's getting at predicting, creating your image based upon your prompt. Okay. And it fills in the blanks in its knowledge, because the base checkpoint that you use for the training, like Pony Realism, doesn't know who Joni is, right? So it's basically trying to go over it again and again and again to figure out who is Joni, or who is, you know, Abby or somebody like that, based upon information that it doesn't have, in order to actually create the image from that prompt. It's all very abstract, but if you get the basic idea of it, then it's going to help you. So what we want to see over a long enough period of time, we want to start to see this curve come down. Okay, because a downward curve means less and less loss, means better and better prediction. Now you're not going to see that straight off, so you can't be impatient on this. You know, you need to leave it for an hour or two to actually really get going. See, now here we've got our learning rate. Now it's now capped at 1. Okay, from that ramp up that we had. So I know how this run goes. This loss will not start going down for about an hour or so, because it's got to start from I don't know who Joni is, and it's going to take a while for it to figure it out. But once it gets going, and I'll show you, because this is going to be a previous run that I did. Okay, so this, looking at this date here, 2025-07-09, look at that. That is an absolute, that's something I could write a TED talk on. An absolute beautiful loss curve. So we started out at 0.07, and it got so good at figuring out who Joni was by the end of it that the loss had come all the way down to 0.02. Now I reckon it probably could have done even more, but you can see here, here's our cosine. You see this is the cosine with restarts setting. So we start with our learning rate at 1e to the minus 4, and it's gradually reduced over time as it gets more and more refining of that, until eventually right at the end of the run, which took 14 hours, the learning rate was close to 0. And believe me, the polish, well, we're going to look at that polish, because we're going to look at this run, the result of this run, okay, next, in terms of when we do the inference. But for now, this is just to say that at the beginning of you learning how to do this, you're not you might get really lucky, and you might get a curve like that, and then you've hit the jackpot, and you might not know how you've done it, but you just got lucky. But the only way to really know is you're going to have to just slug it out and try various different settings and work with Grok, Gemini or ChatGPT to help you debug why, for a start, to actually get the run to work at all, or to get you installation of Kohya working correctly, because there are so many different hoops you've got to run through here. But as you're going to see, the dividends of all your hard work are going to pay off in terms of absolutely mind-blowingly good results. Okay, right. So we're going to look at the results of this in a minute. If your loss curve is not going down, there can be many different reasons for that. Your learning rate might be too low, or it might be too high. If it's too low, as I say, you can get stuck in a rut and can't learn further because it can't get out of a hole that it's stuck in. I had this on the last run, the run I did before this, I think. So here's another loss curve here. It's gradually coming down. Here again, that was a lot of steps there. How many? That was 6 o'clock to, that was almost 2 hours. There was a slight loss reduction there. This is the loss per epoch. Yeah, again, this one wasn't going anywhere. This is why to have Tensorboard, it's absolutely critical that you have Tensorboard. You can actually see the loss rates. You can see the loss rates here as it's doing it on the command prompt, but you need to see a graph. Okay, so again, this graph here, this didn't go anywhere. This was aborted. Let's go and have a look at Abby's. I did another one. So we switched to Abby, Abby's directory, and we'll reload this. So now this has got Abby's run here. Actually, here we go. This is a good one. Let's turn these other nonsense ones off. So this was Abby's run. That's beautiful. Look at that. It started out at 0.85, and got down to 0.05. I think I didn't run that long enough. And in fact, I know I didn't run it long enough, because we're going to look at Abby's run. We're going to look at Abby's inference and compare it to Joni's, and we'll see it's not as good. The reason for that is because I didn't run it long enough. So here we've got 16,000 steps. I think Joni's was double that, and I managed to get the loss on Joni's image set down to 0.03, I believe, or 0.02, something like that. So what this means is that it's only half as good at predicting or guessing who Abby is compared to who Joni is, because the loss rate was almost double at the end of it. And the reason it was double at the end is because the cosine, because my max epochs I think was only 8 instead of 24. It basically just it couldn't do any more learning based upon the curve that I gave it for that run. Okay, so that's Tensorboard. That's your loss curve that you want to see coming down, and it all relates to your config file, max train epochs, learning rate, and all this other stuff, a lot of which relates to reducing RAM allocation and some other neat little tricks like this one and so forth. So I'm going to stop this run. We're going to pretend that we already did it, and we come back 7 hours later. It actually was going to take 7 hours. Come back 7 hours later to basically look at the results. So the results that you will see will be in the output directory. So we'll go to outputs, we'll go to the one that we did earlier, and we can see here we've got a number of different state files. This is a setting that I used when I did this run, but it's an additional switch where you can, if you want to do monitoring of the run as it's going along, to see if it's doing a good job of it or not, is you can set up and also if you want to resume the run later on, you need to have this set. Let's talk about that now actually. So there are some additional switches here for Kohya. Save state and then save every n steps. Okay, so we had one save every epochs, save every x number of epochs. Where is that gone? Save every n epochs. This is an additional save command, where if you want to do, if you have this too low, you're going to end up with tons and tons of files on your hard drive. You could end up running out of hard drive space. But if you ever wanted to resume that, run later because you wanted to pause it because your machine crashed or something like that, then there's a resume command to basically get that going. But you have to have that set on your run, otherwise you won't be able to resume it. These switches produce all these states along the way, and I need to delete those because I don't need them anymore and they're just taking up space. But we can see here now in our output directory, Joni SDXCL, these are all the epochs. It's created a checkpoint for every epoch that it's got to, and it took 24 epochs in total, because the final epoch, it doesn't include the number, it just produces the actual one here, just without the epoch name. Okay, so that is the final result that came through all the way after 14 hours or whatever it took, and you had the cosine the cosine smoothing out at the end to give the final result. Okay, so this is the one that we use, that we're going to look at now in our inference. But if you want to monitor the state of your run, you've got all these different save points that you can look at, and it'll save them every 15 minutes or so in the case of when I did it. So I could just check to see whether it wasn't completely making a hash of it, and I could see that progress was being made. And as I was looking through them, I could see that the results were getting better every time, and I thought, this is awesome. The training one is doing its job, and the result is continuing to get better and better. Right, so basically that might not always be the case. Let's say, and this is an absolute classic sign to look for. Let's say you had your training rate quite high, and too high potentially. What can happen is your loss curve can come down, and then it will plateau, it will flatline, and then it will just go horizontal at that point. That's a classic sign to indicate, or start to oscillate up and down, up and down. That's a classic sign that you've hit overfitting. It's that the AI has got nothing more to learn, and so it'll then start hunting for things that it shouldn't be looking at. And that's where you get overfitting, where you get not artifacts, but you get pieces of clothing or pieces of the background that end up coming through on your inference, on your actual text to image after you've created the LoRA. So when that flatlines, that will be an indication. I never got a flatline on Abby's, and I never got a flatline on Joni's, which suggests I could do even more training. I could do even more training on these. I definitely know I need to do more training on Abby's, but I mean, I'm so happy with Joni's training. I think, well, what more is there to learn? So maybe I've not understood something there, but because I can't believe the loss curve can go down in forever. Eventually, it's going to hit zero. Well, it's never going to hit zero, but I think it's going to bottom out at 0.01 maybe or something. Yeah, say if your curve flattens out or it starts to oscillate or it's not going down anymore, just stop the run. But you can look for low points. The lower the loss, usually the better it is. So if you have an oscillation, look for ones. Try to find a point in your saved checkpoints for one that basically has a low loss. Here is the point of the video where we get to have fun, as opposed to we've done all this hard work, and your brain is probably aching like it's never ached before in trying to actually get through these various different nightmares of configuration and errors, out of memory. Or there's just anything you can think of. It'll bite you in the ass. Okay, you now get to assuming you've gotten through all of that. You've got a nice, beautiful loss curve that's come all the way down. Your GPU hasn't overheated. It's 29 degrees here right now, Celsius. I don't know what that is in Fahrenheit for you Americans. I think about 86. Right. So your GPU is not overheated. And so on. You get to then start playing with the LoRA, and basically you just load the LoRA into your LoRAs directory in Comfy or whatever, whether using automatic 1111 or Swarm UI. You've got your LoRAs directory. You copy your LoRA over here. We can see here it is Joni SDXL version 0.2. I should really rename that to 1 because it's an absolute killer. It's a proper version 1 really. It's not even a 0. Your save tensors file. Okay, you've loaded it into your LoRA. You've got a LoRA loader here in Comfy UI. Okay, and then you choose your checkpoint. Now, ideally, you should probably start with the checkpoint that you used to do the training on. As I said before, that was Pony Realism, but and we already looked at that earlier. Okay, Cyber Realistic Pony has, as you can see, is created some absolutely stunning results. We're going to start off by turning off the LoRA so we can just see what this prompt will do. Okay, it's quite a detailed prompt, and it's got the standard ones in there that this particular checkpoint likes to have. A description of the hairstyle. We've got our trigger tag in there. One girl is pretty standard. We've got a lot of stuff about the eyes, because as you may know, eyes are a bitch. Basically, it's one of the most detailed parts of the human body in terms of tiny amount of pixels that it only has to play with, but it has to get them absolutely perfect, otherwise the eyes are a disaster. So that I have a lot of stuff on the eyes going on. Okay, and here we're actually describing her eyes, her eye color again, and then we describe what she's wearing, and then we get into camera stuff and lighting. So what happens if we don't know anything about Joni? right? We've turned off our LoRA and says, what does cyber realistic pony say about one girl with long hair bangs, green grey eyes, and a sequin dress? Let's find out. It's a pony face again, although admittedly I think she's got a bit of a nicer pony face than pony realism. Okay, again we'll just do another one just to say this is what the base model chucks out without your LoRA. Yeah, another pony face. Okay, so now what we'll do is we'll turn Joni on. Now the first thing you're thinking of is, oh, we'll just set it to 1, strength 1. That's default strength for a LoRA. But watch this. Watch what happens if I do this. And when I first did this, I thought, oh no, it's a disaster. Everything's gone all wrong. I just burned 14 hours of electricity for nothing, because that's the result. You think it's a disaster. But then you think, hang on a sec. You can, as you start to kind of get an idea of these things, you can see that it's too strong. It's trying to slam the checkpoint with the LoRA at too high a strength. So what you can do, I mean, I know this because I was spending hours on it. I know that 0.5 is going to give me the best result. But let's say you go to 0.25, and now it's just like barely a whisper. It's just whispering Joni into the ear of cyber realistic pony and said, this is what she's really like. But it's just a faint whisper. Okay, so now what you get is, imagine if cyber realistic pony and Joni had a baby. This is what the daughter would come out looking like. So it's not really Joni, but it's not quite pony either, is it? But when we had it set to 1, it was just like it had been carpet bombed, but from a B-52, and it just created carnage. So what we eventually do is, by playing around with the strength, we find out what the optimum point is, and it can depend upon whether you've got a close-up of the face, or whether you're doing a full body shot. But this strength, there she is, and then we can go to 0.6, and it's probably still going to be okay. So we can see now with 0.06 that we started to lose a little bit of fidelity on the flesh, on the quality of the skin. Because if we had that set to 0, we just turn it off again, and we just look at the quality that we get from the rendering of the girl's skin. See, it's a really beautiful skin. The eyes are absolutely perfect. This is what you're paying for. Well, you're not paying for it, it's for free. It shouldn't really be free. I mean, you should pay for this stuff, because the guy who created this, who worked on this, or people that worked on it, have slaved for I don't know how long to create this fantastic checkpoint, which creates absolutely beautiful. Look at the lips and everything. With your LoRA, you want to just get enough strength that your character comes through without crushing the quality of the checkpoint. In this case, a hyper-realistic checkpoint. So 0.6 was too much. It was too high. 0.4 probably isn't enough. It's not really going to consistently bring Joni through as the Daz Studio Joni, who we know and love. Okay, yeah, you could say, well, that's still her. It's still her, but I find that 0.5, at least for this particular portrait view, is going to give the best of both worlds. It's going to get the quality rendering of in fact, actually, I'd argue that one there is still a bit crushed on that particular render. You just do another one, do another generation. Sometimes you just get the odd generation that just comes out nasty. I mean, her eyes there are nasty. Might even argue taking that down a bit. I don't know. If I actually don't show the dress, I just realised, I don't have portrait there. Say portrait and headshot. So we're going to get a nice close-up. Right. So now we've got a close-up, and it's easier. It's easier because the checkpoint has got less, and the AI engine's got less to worry about. It can just focus on her face. Yeah. So that's still her. So I could maybe even take that strength down a bit more to try to get more fidelity on the skin. Yeah, we're starting to lose there now. So that's not really her, is it? Go back to 0.6. Probably going to crush it. Not in a good way. It's okay. It's okay. I think 0.5 again is the best one. Okay, so now if we zoom out a bit more, it gets harder, because we go back to the shoulders and it's showing the dress. It's going to show her upper body. It's got to do more work. and it's got fewer pixels around to actually do her face. Okay, her face is still intact as hers, but now if we say we're going to add in shoes to show her, I never know whether it's just stiletto with 2 T's or 1 L. Should hopefully get her full body coming through. Oh my god. Apart from the nails, that was an absolutely stunning generation, apart from those weird ass nails. My god, this is the reward. This is the reward that you get when your eyes just pop. God, she looks absolutely gorgeous. And actually, so that was really good. Okay, so what that is, it's that I'm going to take out these prompts that relate to the eyes, and you can just see some nice little pro tip to give you here. I'll take out these eye ones, and you just see what happens. Ow! Oh my god, her body looks great, but what happened to her face? What the hell happened to her face? I'm going to fix that for a minute, so we're using the same seed, okay, for comparison. So let's put those eye prompts back in and rerun that. Okay, so actually it was enough that text encoder change was enough to actually make it a different generation, even though it's exact same seed. But we can see that it's still not perfect, but it was better than that absolute dumpster fire that we saw on the last generation. And what ChatGPT was suggesting was that because it was focusing the attention of the checkpoint, the generator, on the eyes, that it had to focus its attention on the face. And the more attention it puts on the face, then the much better it's going to do at reproducing journey. Because as you go further out away from into full body shots, it's got a lot more of this going on. It's trying to do the dress, it's trying to do, I mean, we don't have any background here, but I mean, if we set the background, I don't know, nightclub, then it's going to have to think about the background as well as the dress, as well as her legs, and their face can end up getting lost. Oh, that's still her. Okay, and actually, I hate to admit this, but you see that brown sofa? And that wall, that concrete wall, that's in her training set images. So there's actually, I'm embarrassed to say, I've been banging on about how good this LoRA was, but there is a bit of overfitting. So some of the background has come through, and that sofa has come into her images. But anyway, that's getting into the subject of overfitting. So her eyes are still not quite perfect there, and what we can do here, we can actually try to increase the image size a bit more to try to give a few more pixels. So we can do that. I think we can go up to about 1536 for SDXL. And we don't necessarily need width there because it's just a standing picture, isn't it? So we can just leave the width as it is there. Now, one thing I've noticed here, it can end up stretching her body though a little bit, which is an unwanted effect I don't have a solution for right now. So she's going to probably end up, actually no, she's still come through nicely proportioned there. Her eyes are still not really perfect there because you're dealing with just a handful of pixels there, but those shoes look amazing. Let's try to just stretch it even a little bit more. God, I mean, this as you may have done with SDXL, if you kind of stretch it too much, I think it can break, and we might end up getting 2 heads or something. Oh, that's great. No, that's worked perfectly. So there you go. So if you're going for full body shots and you're still having trouble with the eyes, you've already got your prompts in there to try to really focus on eyes. Increase the image size. Okay, if you increase the image size, let's just zoom in here a little bit. Yeah, I mean, when you zoom in quite a lot, you can still see it's not perfect, but that may be the best you're going to get. I think we may be at the limitations there of text to image in terms of eyes. And let's say we turned off the prompt, turned off the LoRA. What can Cyber Realistic Pony do with eyes in a full body shot? Actually, it can do a pretty good job. Yeah, they're still not perfect. That one's bigger than the other one. But you can see, yeah, so even there you can still see it's got some issues going on. Anyway, this is a little bit of going off on a tangent here. We're talking about how this LoRA is going, how we're testing the LoRA essentially, and you test the LoRA by doing multiple different situations and different poses. So let's do another pose. What do we say? I don't know. Let's say sitting on a park bench. She's not got a glittery dress on now. We just put her in a t-shirt and jeans, and we change the lighting. We want to keep high detail skin. We don't want any of this stuff. We want to leave photography in, because I like photography is a good one. So it's a daytime, cloudy. We say cloudy day. Cloudy days are better for photography because you get softer shadows. Soft shadows. Yeah, and actually let's just put that back to 1024 because we're going to go for a square because she's going to be sat down. Okay, so again, we're testing the LoRA here for different situations, different lighting, different poses. My heart's melting. Absolutely stunning. First time. God, if you met her on a park bench, I don't know, my heart would kind of flutter. I don't know about you. Very impressive. Oh, that's why it's not running, because we've got a fixed seed. All right, increment that. Yeah, and off we go. Let's get another one of there. Yeah, not quite as good on that one. She looks a bit childlike there. If you start to get the whole kiddie stuff coming through, which obviously is extremely dangerous for NSFW stuff, I found that you can just put in a negative prompt there, child and an adult. This checkpoint, and they give you a warning on this checkpoint that this can happen. You definitely don't want to get in trouble with that stuff. Yeah, I think we got lucky on that first one because those next two weren't quite as good. The eyes are not having it. Yeah, again, the eyes are off again there. That's perfect. I'll take that one any day. Let's try a different sampler actually. I've been playing with that one for ages. Let's go to DPM PP2M. Yeah. You can experiment with different samplers, get different effects. It's just really struggling with her eyes again there. Yeah, that's not bad. I quite like that one. Let me take the strength down a bit here. Let's see if that's going to affect it. Yeah, it's 0.4 is too low. It stops being journey. Let me try another one. Let me try Euler. Euler is usually very stable. Yeah, okay. Oh, yeah, that's another one I remember as well. If you're having trouble with the eyes on these wider angle shots, try cranking up the steps. I think 70 is about the limit to what I got to before I really didn't get anything beyond that. Obviously it takes a little bit more time, but if you're trying to get that perfect render, yeah, there you go. That's much better, isn't it? And of course, we can, if we're having trouble with the eyes, we can increase the image size. Now it takes a lot longer now because it's not only got a lot of steps to do, but a much bigger image. Yeah, that changing the image size there. Zoom in on those eyes. I mean, they're a bit matte, I guess, but otherwise the shape's perfect. And there's no other artifacts, is there? We've got two more eyes there. Maybe it's because we've got eyes in the prompt. Let's put eyes on our t-shirt. Just one more. I can do this for hours. I don't know about you, but when you start to get really nice results, it's just like the eye candy just keeps coming in, you know, time and time again. When you've got the right formula, it's a knockout. Wow, beautiful. Right. That's Joni. You can see she's come through. She's coming through consistently, again and again and again. Okay. Let's briefly talk about the other LoRA I created just before this one, which was with Abby, and so let's bring her up. And because she was not trained for as long. I think it was only about 7 hours. Joni had about 14 hours. Okay. Or might be even longer. I think Joni might have been running for 3 times. But let's want to compare the quality of this result. Okay, so I've got Abby's LoRA loaded in here with a new scene. We've got her tag there. I just realized I'm missing some cyber tags here. And so we can see that's definitely Abby coming through, but the quality I don't think is as good. Okay, so let's just run a couple of generations here. What did I have Joni on before? We had Euler normal. That created an absolutely stunning result. Let's go and switch over to that. Right, okay, so yeah, it's definitely her, although the eyes again are a little bit dodgy, even with a big image set here. Let's just try oil and normal. Yeah, this is what happens sometimes when your image size is too big. Okay, so instead of getting into this full body stuff, I'm going to switch over to a portrait view. Okay, so I just adjusted that prompt to give us a portrait. I've knocked the image size down again. Yeah, okay, good. Right, so we can see that's definitely her. That's definitely Abby. Although that strength is a bit too high, so I'm going to just crank that down, try to 0.7. So you're working with a different LoRA now, so the strengths might be completely different that you need. Yes, that's not her. That's well, that might have been her when she was 13 years old. Even though I've got adult and child then now on the negative and positive, so that's not enough. 0.8. Let's try that. So with Joni, so we got 0.5 was about optimum for Joni's strength, meaning that it was so powerful, that LoRA that we created, the signal, that we didn't need a lot of strength. Right, so we can see here we've got problems with her eyes, even though, yeah, well, actually we didn't want that. We just wanted the headshot, so it's not giving us a headshot. Forgot the comma there, possibly. Close up. Yeah, okay, good. Again, she looks rather teenage there, so that it's still babying her face a little bit. So this is why I think this one needs, I think we need to do more training on this one. I think she needs more refinement. Because if I put that up to 1, it's going to start to shout over the quality of Cyber Realistic Pony's checkpoint, and it's going to have reduced fidelity on the skin tones. I actually had some good results on this one a couple of days ago, and I can't find the prompt. I'll put up some images so you can see what I was able to do with her, but say comparing those images to those of Joni's, she needs a bit more work. She needs a bit more work. So right, so I'm going to go back to Joni now, because I also want to talk about generalization. Generalization. So here we've only looked at one. Well, we briefly looked at pony realism, didn't we? So we'll switch our checkpoints. So we'll load in pony realism, and we'll have exactly the same prompt. We'll see how these different checkpoints interpret the LoRA, and to see how robust that LoRA is in being able to keep the characteristics of the character going across widely different styles. So we can see this is a bit more stylized. The genes you can see is a bit more cartoonish. Even though I think we've got a cartoon negative prompt, haven't we? We don't have a cartoon negative prompt, but we don't want to put that in because we're going to look at anime in a minute. You can still see that's definitely Joni's coming through. Let's do another one. Yeah, although that arm is obviously wrong. That's still her character there, isn't it? Even though it's more of a cartoonish look. But to say that could be that's the style. It could be the style of the checkpoint. The point we're making is that is still her characteristic. That's still her identity, isn't it? Just one more, and then we'll switch. Yeah, that's still her. That's still her, but we can see it has a different style. It has a different style to Cyber Realistic Pony. Okay, so I want to go back to portrait. So we'll go back to a portrait, smaller image size. No, that's not her. So I think something's gone wrong there. She looks like, what do you call it, from Xena. Let's just do another one. That might have just been a random nasty. Or we can switch our sampler back to, yeah. Yeah, let's just go back to our standard DP-MP2 Keras. Although I think for that particular checkpoint it recommended a slightly different one. I can't remember off the top of my head. Watch combo. Yikes. So let's just turn that strength down. 0.5 might be too strong because yeah, her skin is way too plasticky there. And you see we're starting to lose our identity there now. I mean, if you put it up to 1, it would probably cause like a cascading neutron chain reaction and explode the universe. Yeah, that's the horror that you get from this, the LoRA just basically crushing the checkpoint. I think 0.4 might be possibly the optimum for this one. Yeah, that's nice. Although it's not quite her. It can take some time, I think, to find the optimum settings, prompts and everything. I mean, because actually we switched over prompts, but technically these don't work. So I'm kind of like, I should have perhaps had some prompts saved from earlier when I was doing anime. Let's switch to Dekaitan's one. I like this Dekaitan pony reel. It gives some very nice effects. Again, the purpose of this demo is just to test the robustness of the LoRA in terms of preserving the identity of the character across different styles, and getting into prompt refinement on these different checkpoints is something that is just going to take too long. So we're just trying to wing it here a little bit. Okay, so that's still her, isn't it? It's still her. No, that's not her. Let's go up to just to crank it up a bit. 0.7. That's definitely her, and it's very stylized, isn't it? But it's got her character. That not so much on that one. Let's actually make sure she's got ginger hair, because this particular checkpoint I think is struggling with her hair color. And let's take close-up out so it maybe comes out a little bit more. It zooms out a bit more. No, that's too strong. You can see it's too strong when it starts to kind of blur, and you start to get this kind of not pixelated artifact. It's like you're trying to look through a mesh. You're trying to look through a mesh at her or something. Yeah, that could still be her, but it's a little bit weak. Increase it a little bit. Yeah, that's her. That's still her there. Right. Anyway, you can get the idea that I say you'd have to do some tweaking around, but when you're switching around checkpoints, you have to put the work in, because I say when you switch checkpoint, you have to make a lot of other changes. And saying that, I'm going to do that one final checkpoint, which is go to this anime style one, which I absolutely love. I'm not really into anime, but I found that this one creates really nice effects very easily, and it's actually really quite robust and low in terms of effort that you have to put in to actually get pretty good results on it. Okay, so here she is in anime form, and it's still her. She's there. That's the character, isn't it? This is a character as if she suddenly found herself in a Japanese manga comic, and she still looks like her, and that's actually quite a low strength, really. So that's I can't remember what the sampler settings. Oil and normal is always safe. But so it's just a demo that the LoRA is able to keep creating her, even though it's a completely different style. She's a bit young looking there, but it's imagining it's her attending a Japanese high school. Yeah. Yeah, that's lovely. And it's still her, isn't it? Okay, so I think it was able to demonstrate there that the Joni LoRA that I created was robust across multiple different checkpoints, different body positions, zoom in, full body, and so on, that it could consistently keep creating a look. So it does take some work to do it with the prompts and adjustments and so forth. But once you know that you can consistently get that with the work putting in, you can get her character coming through, then you know you've nailed it, basically. And I'd say I'm very happy with this LoRA that I've created. I don't feel any need to kind of do any further refinement to it at this time, because I might decide to do so later, but for now I'm very happy with it. With Abby's I do need to do more work on it, and I will do that. If you would like to look at the play with this LoRA, I'll provide a link to it. It's available on Civet AI now, so you can actually incorporate her into some of your art and share it on Civet AI so I can see it. All right, I think that's covered it. This has been a particularly long video, but I say I don't know how to shortcut a lot of this. It's a massive subject which takes a lot of work and detail in explaining, going through the different steps. I'm sure I've glossed over some things like installation. Sorry about that, but it's just going to take too long to get into the whole installation discussion. Right. So hopefully now you feel not so intimidated and inspired to be able to go on and create your own character LoRA. Okay. So again, in summary, you can either do this on your local PC, or you can do it on a remote LoRA training service. If you're doing it locally, I recommend Kohya SS for your actual trainer, Tensorboard for your monitoring. You select your images of your DAS character or some other character that you have in mind. Select your characters, do your auto captioning with WD-14, prune those captions, configure your training run by setting up your TOML file, get through any issues that you have with running out of VRAM, make sure your learning rate is good, monitor, start the training run, monitor with Tensorboard, making sure that loss graph is coming down, coming down, coming down. Finishing the training, or during testing, during training, you can test the LoRA, and testing the LoRA is by ensuring you have your keyword, your trigger word, and your LoRA loaded, and then some of these tricks with the eyes and so forth to get the eyes coming through cleanly on more zoomed out pictures of your character. Okay, I'm super happy. I'm at a very, very happy point now where this is being able to create consistently create my characters' images is something I have been waiting for such a long time to do. It took an enormous amount of effort to put in to get to this point, but now that I've got it, I'm going to be making LoRAs for all 7 sisters of the Generation 3DX world. So you're going to see character LoRAs for Abby, Rebecca, Kayla, Kira, and Natalie. It's going to be awesome. So fantastic for holding on to this all this time. If you managed to make it through to the end, thanks very much for listening, watching. If you like the video, please give us a thumbs up and share some thoughts in your comments, and certainly share some if you're creating any stuff. You've got my Civit AI page where you can share if you're doing any using my LoRAs. Go ahead. Yeah, they're free to use. And also, if you want me to keep making more of these videos, then please support me on Patreon. I've got Patreon that's now live. As a reward, you have direct access to a chat channel, as well as exclusive and quite naughty content of the girls, okay, which you don't see anywhere else. All right, brilliant. Thanks again, guys. I'll see you in the next video.